In compiler construction, name mangling is a technique used to solve various problems caused by the need to resolve unique names for programming entities in many modern programming languages. It provides a way of encoding additional information in the name of a function, structure, class or another data type in order to pass more semantic information from the compilers to linkers. The need arises where the language allows different entities to be named with the same identifier as long as they occupy a different namespace or have different signatures. Any object code produced by compilers is usually linked with other pieces of object code by a type of program called a linker. The linker needs a great deal of information on each program entity. For example, to correctly link a function it needs its name, the number of arguments and their types, and so on. See name decoration in Microsoft Windows. Although name mangling is not generally required or used by languages that do not support function overloading, they use it in some cases to provide additional information about a function. For example, compilers targeted at Microsoft Windows platforms support a variety of calling conventions, which determine the manner in which parameters are sent to subroutines and results returned. Because the different calling conventions are not compatible with one another, compilers mangle symbols with codes detailing which convention should be used to call the specific routine. The mangling scheme was established by Microsoft, and has been informally followed by other compilers including Digital Mars, Borland, and GNU/GCC, when compiling code for the Windows platforms. The scheme even applies to other languages, such as Pascal, D, Delphi, Fortran, and C. This allows subroutines written in those languages to call, or be called by, existing Windows libraries using a calling convention different from their default. When compiling the following see examples. 32-bit compilers emit, respectively, f, g at 4, at h at 4. In the stcall and fastcall mangling schemes, the function is encoded as name at x and at name at x respectively, where x is the number of bytes, in decimal, of the argument, s, in the parameter list. In the case of CDECL, the function name is merely prefixed by an underscore. Note that the 64-bit convention on Windows is no leading underscore. This difference may in some rare cases lead to unresolved externals when porting such code to 64 bits. For example, Fortran code can use alias to link against a C method by name as follows. This will compile and link fine under 32 bits, but generate an unresolved external f under 64 bits. One workaround for this is to not use alias at all, or to use the bind option. Name mangling in C++, C++ compilers are the most widespread users of name mangling. The first C++ compilers were implemented as translators to C source code, which would then be compiled by a C compiler to object code. Because of this, symbol names had to conform to C identifier rules. Even later, with the emergence of compilers which produced machine code or assembly directly, the system's linker generally did not support C++ symbols, and mangling was still required. The C++ language does not define a standard decoration scheme, so each compiler uses its own. C++ also has complex language features, such as classes, templates, namespaces, and operator overloading, that alter the meaning of specific symbols based on context or usage. Metadata about these features can be disambiguated by mangling the name of a symbol. Because the name mangling systems for such features are not standardized across compilers, few linkers can link object code that was produced by different compilers. Simple example, consider the following two definitions of f in a C++ program. These are distinct functions, with no relation to each other apart from the name. If they were natively translated into C with no changes, the result would be an error. C does not permit two functions with the same name. The C++ compiler therefore will encode the type information in the symbol name, the result being something resembling. Notice that G is mangled even though there is no conflict. Name mangling applies to all symbols. Complex example. For a more complex example, we'll consider an example of a real-world name mangling implementation that is used by GNU/GCC 3x, and how it mangles the following example class. the mangled symbol is shown below the respective identifier name. All mangled symbols begin with Z. For nested names, this is followed by N, then a series of length, it pairs, and finally E. For example, Wikipedia article format becomes ZN9 Wikipedia 7 article 6 format E. For functions, this is then followed by the type information. As format is a void function, this is simply V. Hence, ZN9 Wikipedia 7 article 6 format EV. For print2, a standard type stdio stream is used, which has the special alias SO. A reference to this type is therefore a SO, with the complete name for the function being ZN9 Wikipedia 7 article 8 print to ERSO. How different compilers mangle the same functions. There isn't a standard scheme by which even trivial C++ identifiers are mangled, and consequently different compiler vendors mangle public symbols in radically different ways. Consider how different C++ compilers mangle the same functions. Notes: the compact C++ compiler on OpenVMS VAX and Alpha and True64 has two name mangling schemes. The original, pre-standard scheme is known as ARM model, and is based on the name mangling described in the C++ annotated reference manual. With the advent of new features in standard C++, particularly templates, the ARM scheme became more and more unsuitable. It could not encode certain function types, or produced identical mangled names for different functions. It was therefore replaced by the newer ANSI model, which supported all ANSI template features, but was not backwards compatible. On IA64, a standard ABI exists, which defines a standard name mangling scheme, and which is used by all the IA64 compilers. GNU GCC3X, in addition, has adopted the name mangling scheme defined in this standard for use on other, non-Intel platforms. The Visual Studio and Windows SDK include the program name which prints the C-style function prototype for a given mangled name. On Microsoft Windows, the Intel compiler uses the Visual C++ name mangling for compatibility. Handling of C symbols when linking from C++, the job of the common C++ idiom is to ensure that the symbols following are unmangled. That the compiler emits a binary file with their names undecorated, as a C compiler would do. As C language definitions are unmangled, the C++ compiler needs to avoid mangling references to these identifiers. For example, the standard strings library, string H, usually contains something resembling. Thus, code such as uses the correct, unmangled strcmp and memset. If the extern had not been used, the C++ compiler would produce code equivalent to. Since those symbols do not exist in the C runtime library, link errors would result. Standardized name mangling in C++, though it would seem that standardized name mangling in the C++ language would lead to greater interoperability between compiler implementations, such a standardization by itself would not suffice to guarantee C++ compiler interoperability, and it might even create a false impression that interoperability is possible and safe when it isn't. Name mangling is only one of several application binary interface details that need to be decided and observed by a C++ implementation. Other ABI aspects like exception handling, virtual table layout, structure and stack frame padding, etc. also cause differing C++ implementations to be incompatible. Further, requiring a particular form of mangling would cause issues for systems where implementation limits dictate a particular mangling scheme. A standardized requirement for name mangling would also prevent an implementation where mangling was not required at all. For example, a linker which understood the C++ language. The C++ standard therefore does not attempt to standardize name mangling. On the contrary, the annotated C++ reference manual actively encourages the use of different mangling schemes to prevent linking when other aspects of the ABI, such as exception handling and virtual table layout, are incompatible. Nevertheless, as detailed in the section above, on some platforms the full C++ ABI has been standardized, including name mangling. Real-world effects of C++ name mangling. Because C++ symbols are routinely exported from DLL and shared object files, the name mangling scheme is not merely a compiler internal matter. Different compilers produce such binaries under different name decoration schemes, meaning that symbols are frequently unresolved if the compilers used to create the library and the program using it employed different schemes. For example, if a system with multiple C++ compilers installed wished to install the Boost C++ libraries, it would have to be compiled twice once for the vendor compiler and once for GCC. It is good for safety purposes that compilers producing incompatible object codes use different name mangling schemes. This guarantees that these incompatibilities are detected at the linking phase, not when executing the software. For this reason, name decoration is an important aspect of any C++-related API. Name mangling in Java. In Java, the signature of a method or a class contains its name and the types of its method arguments and return value where applicable. The format of signatures is documented, as the language, compiler, and class file format were all designed together. Creating unique names for inner and anonymous classes. The scope of anonymous classes is confined to their parent class, so the compiler must produce a qualified public name for the inner class, to avoid conflict where other classes with the same name exist in the same namespace. Similarly, anonymous classes must have fake public names generated for them. So, compiling the following Java program will produce 3 class files: foo class, containing the main class foo, foo $bar class, containing the named inner class foo bar, foo $1 class, containing the anonymous inner class. All of these class names are valid and these names are safe for the compiler to generate, as the Java language definition prohibits $symbols and normal Java class definitions. Name resolution in Java is further complicated at runtime, as fully qualified class names are unique only inside a specific class loader instance. Class loaders are ordered hierarchically and each thread in the JVM has a so-called context class loader, so in cases where 2 different class loader instances contain classes with the same name, the system first tries to load the class using the root class loader and then goes down the hierarchy to the context class loader. Java Native Interface. Java's native method support allows Java language programs to call out to programs written in another language. There are 2 name resolution concerns here, neither of which is implemented in a particularly standard manner: Java to native name translation, normal C++ name mangling in Python. In Python, mangling is used for private class members which are designated as such by giving them a name with 2 leading underscores and no more than 1 trailing underscore. For example, thing will be mangled, as will thing and thing, but thing and thing will not. Python's runtime does not restrict access to such members. The mangling only prevents name collisions if a derived class defines a member with the same name. On encountering name mangled attributes, Python transforms these names by a single underscore on the name of the enclosing class, for example. Will output test mangled name, doc, module, normal name. Name mangling in Boolean's Turbo Pascal/Delphi range, to avoid name mangling in Pascal, use. Name mangling in Free Pascal. Free Pascal supports function and operator overloading, thus it also uses name mangling to support these features. On the other hand, Free Pascal is capable of calling symbols defined in external modules created with another language and exporting its own symbols to be called by another language. For further information, consult Chapter 6.2 and Chapter 7.1 of Free Pascal Programmer's Guide. Name mangling in Objective-C. Essentially 2 forms of method exist in Objective-C, the class method, and the instance method. A method declaration in Objective-C is of the following form. Plus method name, argument name 1, parameter 1. A method name, argument name 1, parameter 1. Class methods are signified by plus, instance methods use. A typical class method declaration may then look like, with instance methods looking like. Each of these method declarations have a specific internal representation. When compiled, each method is named according to the following scheme for class methods. C class method name name1 name2. and this for instance methods. I-class method name name1 name2. The colons in the Objective-C syntax are translated to underscores. So, the Objective-C class method plus init with x, number and e, number. If belonging to the point class would translate as C point init with x and e, and the instance method, value, would translate to I point value. Each of the methods of a class are labeled in this way. However, in order to look up a method that a class may respond to would be tedious if all methods are represented in this fashion. Each of the methods is assigned a unique symbol. Such a symbol is known as a selector. In Objective-C, one can manage selectors directly. They have a specific type in Objective-C SEL. During compilation, a table is built that maps the textual representation to selectors. Managing selectors is more efficient than manipulating the textual representation of a method. Note that a selector only matches a method's name, not the class it belongs to. Different classes can have different implementations of a method with the same name. Because of this, implementations of a method are given a specific identifier to. These are known as implementation pointers, and are given a type also, IMP. Message sends are encoded by the compiler as calls to the idobjcmsgsend function, or one of its cousins, where receiver is the receiver of the message, and SEL determines the method to call. Each class has its own table that maps selectors to their implementations. The implementation pointer specifies where in memory the actual implementation of the method resides. There are separate tables for class and instance methods. Apart from being stored in the SEL to IMP lookup tables, the functions are essentially anonymous. The SEL value for a selector does not vary between classes. This enables polymorphism. The Objective-C runtime maintains information about the argument and return types of methods. However, this information is not part of the name of the method, and can vary from class to class. Since Objective-C does not support namespaces, there is no need for mangling of class names. Name mangling in Fortran. Name mangling is also necessary in Fortran compilers, originally because the language is case-insensitive. Further mangling requirements were imposed later in the evolution of the language because of the addition of modules and other features in the Fortran 90 standard. The case mangling, especially, is a common issue that must be dealt with in order to call Fortran libraries from other languages. Because of the case insensitivity, the name of a subroutine or function FOO must be converted to a canonical case and format by the Fortran compiler so that it will be linked in the same way regardless of case. Different compilers have implemented this in various ways, and no standardization has occurred. The AIX and HPUX Fortran compilers convert all identifiers to lowercase, while the Cray Unigos Fortran compilers converted identifiers all uppercase. The GNU G77 compiler converts identifiers to lowercase plus an underscore, except that identifiers already containing an underscore have two underscores appended, following a convention established by F2C. Many other compilers, including SGI's IRIX compilers, Fortran, and Intel's Fortran compiler, convert all identifiers to lowercase plus an underscore. Identifiers in Fortran 90 modules must be further mangled, because the same procedure name may occur in different modules. Since the Fortran 2003 standard requires that module procedure names not conflict with other external symbols, compilers tend to use the module name and the procedure name, with a distinct marker in between. For example, in the following module, the name of the function will be mangled as MMOD5, MMP5, M5, etc. Since Fortran does not allow overloading the name of a procedure, but uses generic interface blocks and generic type-bound procedures instead, the mangled names do not need to incorporate clues about the arguments. The Fortran 2003 bind option overrides any name mangling done by the compiler, as shown above. Name mangling in Rust. Function names are mangled by default in Rust. However, this can be disabled by the nomangle function attribute. This attribute can be used to export functions to C, C++, or Objective-C. Additionally, along with a start function attribute or the noMainCrate attribute, It allows the user to define a C-style entry point for the program. See also, language binding, foreign function interface, calling convention, stropping, application programming interface a Euro API, application binary interface a Euro ABI, comparison of application virtual machines, Java native interface, Swig a Euro open source interfaces bindings generator from many languages to many languages, Microsoft Visual C++ name mangling, references. External links, Linux Itanium ABI for C++, including name mangling scheme. Macintosh C++ ABI standard specification, C++ filter Euro filter to demangle encoded C++ symbols for GNU Intel compilers, unname a Euro MSVC tool to demangle names. Demangler.com a Euro an online tool for demangling GCC and MSVC C++ symbols, the Objective-C runtime system a Euro from Apple's The Objective-C programming language 1.0, calling conventions for different C++ compilers by Agna Fogg contains detailed description of name mangling schemes for various x86 and x64 C++ compilers, C++ name mangling demangling quite detailed explanation of Visual C++ compiler name mangling scheme, PHP undecorate symbol name a PHP script that demangles Microsoft Visual C's function names. Mixing C and C++ code, symbol management a Euro linkers and loaders by John Levine, name mangling demystified by Fivo's Kefaulianitis,